Well, first, it's a great privilege to be here, back in my home territory. I'm living out in Mississauga right now, Toronto. And just in case you came here just to understand how to win the Xbox, my colleague, Edouard, he's the product manager for SQL Server for the country. And if you fill out a survey form, look for him after, or go to the booth at the entrance there, fill a form. They'll do a draw tomorrow at lunch for it. Okay, great. Okay, so, oops, let me bring up my presentation. Okay. Okay, so hopefully you'll stay for this evening's entertainment. This is going to kind of give you a clue of what to expect. And this is also to a nod if you're from Calgary. You'll know that the crew of The Next Generation will be there this weekend. And if you're a bigger Star Trek fan than I will buy you a drink this evening, okay? Because you'd be scared just how off the deep end I am on those kind of things. All right. So before we get to talking about big data, actually, let me do a quick survey. How many are actually writing big data applications right now? So I'd say 10% tops. Okay? So that's great. That's great. I still think you're ahead of the curve. So before we get into big data, we'll just take a review. I like to revisit the past, understand our history, before we jump into all this new technology. The world of data is changing, and actually there is no better time to be in this field. I've built a career here building just databases, data warehouses, and now big data is the next big thing. Right now, many people would say we're kind of on the hype cycle, but it's good. It's good. It's all good getting this interest. Now, it's tough to me to point, but part of the things that are coming right now is this interconnection, and that's today's theme. So some of the things to highlight here is the number of devices that we have, and a lot of the data that's coming out here will be generated from social media sites and digital. You have digital footprints. If you have a smartphone or a cell phone, those will create new markets, and I'll talk about that. Now, if you've built data warehousing applications, and my hat's off to you if you've built a successful one, because often I've seen many more failures than successes, because it's not easy. And this is kind of at a high level, the general process. You have a question you want to answer, you go out, get all the data. Now, you build what we call a logical and physical model. We call that a schema. And often you'll hear this as a schema on write, and then you can read the data. Now, loading the data can also take a lot of time. This is where ETL comes in, where you have to do sometimes advanced transforms before the data is usable. And a lot of tuning for performance. Is the disk tuned right? Is memory enough? Is the CPU right? And then you can pose your questions. I spent a lot of time with analysts talking about our solutions, and this is the Data Warehouse Institute. They have user groups throughout the country. Don't think they have one in Edmonton, but they produce a number of data warehousing reports. And if you're interested in big data at a high level, I recommend you go to their site. But here's some of the trends that they're foreseeing. If you build a data warehouse, you'll be challenged that if it's successful, it'll grow. Now, there's this move to massively parallel, and I want to talk about this because this will give you context of why big data is getting so much hype right now. So, I don't know if you can see this over there, so let me pull this here a bit. All right. So Perry said it was okay if I get a little technical. So if it gets too low down, then wave a white flag and I'll bring it up a bit. Okay. So when you buy a CPU, this is what we call, it's got memory, got disk. All the database vendors know how to optimize for this. Oracle, Microsoft. We call these SMP, symmetrical multiprocessing. Within each of these CPUs, you have CPUs within, or cores, what we call. And we all know how to optimize for this workload. Challenge here is when your capacity increases, demand increases, you have to buy a bigger box. So you have to take out the old one, put in the new one. Now, in the 70s and 80s came a new system where you had independent CPUs that all access the DASD farm. Now, if you saw me yesterday, if you're one of the clients I saw yesterday, you can't answer this question, okay? If there are any engineers in the crowd, you might know what this system was. Does anybody know what system this was? This was kind of the hottest system to use if you're an engineer. Universities usually got it first. Free wireless mouse, if you get the answer right. Any guesses? Which? Cluster. What? By which company? It is a cluster, but there was a digital. Very good. Digital VAX cluster. Who was it? Who got that answer? Okay, I'll see you after. Okay. So it was the digital VAX cluster. This was the state-of-the-art, fastest parallel system, first parallel system that people could buy. Now, typically what happens with technology advances is hardware comes out first, and then the software vendors try to figure out how can we optimize for that. And then the first database that optimized for this was, I'm going to raise your technology IQ whether you like it or not. Okay? Okay, so that, what was it? RDB, close. Close. This company bought RDB. Any more guesses? Oracle. Yes, it was Oracle Parallel Server. And we call it the shared disk technology. And if you're familiar with IBM mainframes, same kind of architecture. And then, well, actually, the challenge of both the SMP and the shared disk architectures was this. As you added the number of CPUs, the performance curve went like that. You eventually got diminishing returns because it was so complicated to keep everything interconnected. It's just the law of physics. This will happen no matter how hard you try to offset it, faster networks, this will happen. And it could happen as quick as 3, 4 CPUs. So on came what many categorize as share nothing. So CPUs all interconnected together with a high-speed network. Everybody has private disk. And the reason why this was popular is if we threw workloads here, we saw a linear performance curve. Now, the catch is that this had to be a specific kind of workload. This is for analytics or query workloads. If you have transactional workloads like a banking transaction or SAP ERP, you would see a performance curve that might even degrade as you add CPUs, because it takes so much time to break up the transaction, send it to all these nodes, and then to reassemble it. It just takes too much effort. It's too complicated. But with query workloads, it's easier to partition the data, and everybody works on their piece of the puzzle and bring it back. And that's why the popularity of this architecture. Now, what's also arise is the appliance. I've spent a lot of time doing performance reviews. People come in and say, well, you know, I'm not getting the linear performance. I double my CPUs, I'm not seeing double performance. Why is that? And we would ask questions, how much memory have you got tuned? What's the speed of your CPUs? Is your disk, you know, what's the speed of your disk? What's the layout of the data? And eventually, I think all the vendors got tired at the same time and said, that's it. Enough with the questions, enough with the tweaking. You are going to get a system that is pre-tuned pre-configured, pre-tested. We're just going to put it out there, and you can load your data. No more of these, 2-month performance reviews. So Teradata, often credited as kind of being the first kind of like appliance. IBM, Microsoft, a number of the vendors here all have this approach. And it's for time to value. Now, the concern, if you read the Gartner Magic Quadrants, what do you think the #1 concern of the appliance is, of getting an appliance? Cost. It is a concern, but it's not the #1 concern.
Flexibility.
Flexibility, that's close. That's close.
Interoperability.
Pardon me?
Working together is a plan to work together.
Working the data. Farther away, not as close, but yeah, still a concern. Proprietary. Proprietary, right. The fear is vendor lock-in. You see, so I'm coming from Microsoft. I'm going to have to give you a few commercials how Microsoft does it, but I will tell you up front that vendor lock-in is the #1 concern, because how many people here use Oracle? Okay, you can admit it. It's okay. I've worked with Oracle. Okay, so Oracle, while it runs on many platforms, if you buy their appliance, it's hardware and software. So you're really married to them, right? Same with IBM. It's not that you have the freedom to, you used to have the freedom to run software in any hardware you pick, but now they want you to buy hardware and software. So a lot of people feel a little queasy about that. Okay. I have about 10 minutes left, right? No. So data warehousing challenge. So the promise of the data warehouse, whether you buy an appliance form or build it yourself, is that data is shared by everybody, and that it's part of the business case. However, what's happened in the industry is they've become silos unto themselves because they are complicated, because it's difficult to tune for performance. Frontline employees, if you're building data warehouses, this is where the industry is going, to build what we call operational BI applications, where the front-end user, the people who could really use analytics, well, I mean, there are power users who could use it, but when the masses get it, when the masses get access to analytics, you'll find that the performance of the company improves. And there's lots of studies to show how much better companies perform in the industry if they make better use of analytics. So one of my favorite examples, not to pick on any cable companies out here, but my cable company. You ever get cable outages out here? Network goes down? Right, so what happens in Toronto, I pick up the phone and I call my cable company and I say, hey, network's down. Do you know what they say in return, typically? You reach voicemail? Okay, no, actually I get a human, so it's pretty good there. But I'll admit I probably have to hit 5 buttons before I get that human. Any guesses what they usually say?
Thanks for telling us.
Exactly it, right. Well, actually they're a little friendlier than that. They say, oh, we didn't know. Right now, does your cable company know when the network's down? Because mine doesn't know, and I always call. I always call to check, okay, do you know it's down? They go, no. And then what they do is they check. They actually have a system. They can go, where do you live? Okay, we'll check it out. And they'll go, hey, you're right. The network is down. And I go, well, okay, thanks for confirming that. And then they say, okay, we'll get right on it. And 5-10 minutes, your system will be back up again. Now, wouldn't it be great if that front-end person saw me coming in and says, okay, that you're Bill Wong, you're living in this area, said, oh, hey, I notice you have 3 of our 4 services. If you get the 4th one, you get a 20% discount on all of them. No, it's not the best time. You have this kind of outage, but I'll give you an extra 5%. Those are what we call these golden moments where you can kind of change a situation that's bad into a sales situation. But they don't do that. So I keep calling. I keep calling. And one day, I'm sure they're going to do it. And actually, I have dinner with one of the Rogers execs this week, so talk to him about that. But that's where the industry is going, is really to try to push analytics for all, not just for the few. And that is the challenge a lot of you will have with analytics, because it is costly, conventional ways of doing it, and we'll talk about some of the newer ways. Okay, for sake of time. Now, SQL Server 2012 just got put out, and I've been following this product for many years. And of all the things I've seen, there's 150 new features. This is the most significant feature of the new release. And what it is a column store technology. And the open source databases are using this. We'll talk about this with Hadoop. But basically, if you're familiar with HP Vertica or Sybase IQ, this is where instead of storing rows into what we call a table, you store columns. So when you request for data, typically people aren't going to request for everything. They request by row. We return a lot less rows, use a lot less CPU, we compress. We've seen performance 100, 200-fold difference. It is blinding fast. Now, the cost, there's always a catch, okay? Whenever any vendor tells you, hey, you're going to get this, ask what the cost is. What's the trade-off? The trade-off is this is read-only. Okay, so if you want to do updates, not recommended. There's a lot of databases out there. When you update, they lock or they serialize the update. So you lock at a table, like a very big, it's not very granular level, a table level. So if you do use SQL Server 2012 or thinking about it for analytics, this alone is worth it. There are companies built just on this feature. And what you're going to see eventually is all the relational databases will eventually come out with this feature because it's this much in demand and that much benefit. Mentioned before, we've done a lot of surveys. So was Gartner, all the consultants, and said that the companies that understand their data better perform better. Now, in order to do that, there are a number of things your IT staff have to do. They've got tools to clean the data. They've got tools, master data management, to make sure data is used in a consistent manner. Integration services, how to load, how to track data, how it's used. And again, while it's necessary, this can be a frustrating exercise for people who want access to the data warehouse, because people want to make sure that data is very clean before it gives access to the users. Now, the Microsoft strategy is to include all these as part of SQL Server, and I've always been impressed with that over the years. Master data services, the leading vendors will charge 6 figures for that, just the software. Anybody doing master data management here? Okay. Are you paying less than 6 digits? Okay, well, okay, so you saw it there. So it's incredibly expensive, and for me, I think you can do better, because the master data services, a lot of it has to do with policies, people in place. It's more than just a software tool. So I urge you to, that alone is worth looking at the software. And parallel data warehouse. This is the reason why Microsoft right now is hiring people like me with experience with large data volumes in the data center. We're joining Microsoft because they've just launched this product. So for the longest time, Microsoft could not scale massively parallel. They were confined to the single box. But now with this new offering, Parallel Data Warehouse, you can do petabyte-sized data warehouses now. And Gartner Group has been interviewing some of our customers. The strategy of Microsoft is also to make this available on multiple hardware platforms. So of course, Microsoft doesn't build hardware, so you're not locked in from a hardware perspective. I'm going to skip that. If you were interested, you can come see me after. Okay. So what's the deal about big data? This is a recent survey. And there's 3 slices of the pie. There's a small percentage, 6% of the IT firms out there, IT organizations of companies, are saying that big data is their #1 priority. Like, not even top 10, like #1. 45% of saying it's their top 5. 27% says it's in their top 10. So if you add all those up, 70% of IT firms, IT organizations are looking at it. And I can attest that that's true. We gave 2 or 3 days notice that I was coming to town, and we had a room, 25, 30 people, all interested. Okay, tell us more about big data. What's a good fit for these applications? Gartner, McKinsey, all saying that these are great opportunities. This was a McKinsey survey. They forecast $300 billion could be saved in the US Medicare system just by being more efficient with the current assets. In Europe, they forecast at least $250 billion savings in administration cost. Germany has been one of the first to do a $10 billion savings over the last year in their labor department. $600 billion. This is a new market that they're forecasting based on location data. So things like where you are, doing things like smart routing to save fuel costs, to save time. If you saw, there was this interesting news article that came in the local news channels a couple of days ago. There are really creepy applications coming up too, where you know who's in the room with you. You kind of know who's connected to who, and facial recognition with your smartphone. And so those things are coming. So be interesting to see how life evolves with those. Key things down at the bottom that everybody's forecasting too is a lack of skills. Is that the biggest challenge for many people will be to get the right people on how to leverage big data. So 1.5 million from a business level managers, 140 to 190,000 technical folks. So that'll be a challenge to find the skills. And perhaps the emergence of new skills as well. There's some groups are forecasting the emergence of the data scientists. Have anybody heard that term? Yes, well, so I'm kind of going, well, I don't know about that one. It sounds a little pretentious, but certainly the data folks, and actually a lot of the companies that we're working with right now who have implemented big data, the folks who have, they leveraged off IT, generally the data warehousing folks, they usually have a good incumbent involved. And actually we're helping one university out in the Maritimes. They've asked us to help build a course curriculum to help them build future graduates to address this need. So any university colleges out there, take note. Okay, so here's the difference. And this is some of the big selling points of big data. You collect the data, you just load it onto the disk. Okay, so they call it, there's no schema involved, no logical modeling, just place it out there. And you know, questions I was being asked, well, what about backup, right? They make 2 copies while they're at that, right? So it's highly available. And the thing with big data, they never want to delete it. You never update it. You keep appending. You just keep adding and adding and adding. Now, the advantage of no schema, no model, means that you can ask any question. And I think that's the great strength of big data. It's so flexible. I ask the question, and somebody tracks, okay, where the data is, what's the value of the data, and the offset, or what they call a key or key value. So it's very flexible. You just put it out there and ask your question. Now, what this chart doesn't show you is that where's the price, okay? Right? Well, why isn't everybody doing it, right? So the price is the programming. The work shifts now from those central data warehousing folks, because you need parallel, you know, people understand parallel programming a lot better. Any Hadoop programmers here? Oh, we got one. Okay, you get multiple job offers, I bet, because Hadoop folks are tough to find. Big data scenarios. So I'm going to talk a little bit about scenarios. Think of the other speakers, but in Alberta, sensor data, oil and gas. So that generates, you know, billions of bytes that are just put on the wire that, for the most part today, is probably thrown away. So big data applications would collect all that data and say, okay, can we find any patterns? Can we predict mean time to failure of components? So big data, asides from the variety, can certainly take volumes of data. Now, Yahoo. When you sign on to Yahoo, this is a Hadoop application. All the data stored here is in Hadoop. Hadoop's the file system for big data, and there are other databases, but 95% of the focus for analytics and big data is Hadoop. So you'll hear about other ones, Cassandra, MongoDB, etc., but Hadoop is the one that's getting all the focus. So when you go to Yahoo and you take a look at the page, they personalize that page, and in the future their target is to personalize by individual based on your demographics, your clickstream data. So they will pick what they think is the top story for you or your area. Build indexes to things that they think that you're interested in. And they make their money through ads. So last year they made almost $6 billion in revenues from marketing ads, just from people clicking on the ads to make it that compelling. And I picked them because they're one of the biggest contributors to Hadoop as well. When they wanted to do analytics, they picked Microsoft to do analytics. So it's a great marriage of open source and using our BI tools. And they use machine learning too to edit spam, and they've won awards for their technology implementation. Okay, Clout. Clout is a really neat website, and like a lot of the internet startup firms, this didn't exist before 2008. And what Clout does, as you would imagine by the name, it measures your clout. How many people do you network to? And of those people that you touch, how do you influence them? Do they take action on your content? And can we rate those folks to your network as a whole? How are they acting? And they give Clout scores to companies and to individuals. And they too build a SQL Server OLAP queue. Theirs is 24 terabytes. So we're talking pretty big data sizes for Microsoft. Most Microsoft users I meet haven't got to that level yet, but you can certainly scale to that level. And let's see. So some of the metrics here, they load 350 million rows of data a day. They compared and contrast with all the other tools out there, but they picked Analysis Serve for ease of use. And I should also say that they were able to do this on $7,000 worth of hardware. Okay, low entry price, and that's a strategy that you're going to see. Like, anybody can do this. Other companies, Sprint's doing big data for churn analysis. Ford's going to put cloud applications to find you the best utility rates to charge up your electric cars. PepsiCo's great story. I've met Pepsi in my previous life. They have a policy of no Microsoft. There's just Oracle software, IBM hardware. But they've recently picked Microsoft as a corporate standard for their front end. Okay, so Hadoop, I'm going to start accelerating the charts here, I guess. We're going to start still relatively on time for the other sessions. So think of Hadoop as an ecosystem, which is always changing. Okay, so this will continue to develop. And when you hear the term Hadoop, really Hadoop down there are these two infrastructure, MapReduce, that's a coding paradigm I'll take you through, and the file system. The file system, again, as I mentioned, all you do is just put data out there. You don't need to format it. Places it out there, keeps track of where it is, and you'll have 3 copies of it. There are ways to get access to this. So if you're not a Hadoop programmer, folks like Facebook have developed SQL interfaces. Scoop SQL for Hadoop are ways to interchange data between conventional relational databases and Hadoop, and bidirectional. If you're interested in the other ones, come see me after. I'll take you through that. So at a high level, what Hadoop does from a programming perspective, we take the problem and we partition it by sending the logic to where the data is in this. Okay, so Hadoop would place all the data across your cluster, and you can use really cheap disk devices. You don't have to use RAID. The cheapest disk you can find, and the Hadoop will take the code and send it to the CPU with that disk, and tries to do all the processing locally. And then the reduce part aggregates. Now, if you're a SQL person like me, think of the top part as the select statement where you grab all the data, and the bottom part reduce as the group by or the summing. And that's how it works. So it's very simple. Two-step process. Can't go multi-step. You'll have to do it again. But very, very simple. You've seen other presentations talk about the various attributes of big data. We talk about its volume. I think that the big attribute that's really attractive about big data is the flexibility, the variety of data it can take, which is basically anything. Velocity refers to if you want this in real time and or near real time, and Hadoop can handle that as well. So the Microsoft approach is that we believe these systems will coexist. And if you were following Hadoop when it first came out, a lot of folks forecasted the end of data warehousing because this is so simple. But there are some catches here too. So Hadoop doesn't do, you saw in that chart I put before, you just load the data. There's no cleansing of the data. You don't have to clean it. Now, most of the Hadoop advocates will tell you that you should still do master data, you should still do data cleansing, etc. But there's a lot of folks out there say, let's just get a feel for the data and put it out there. And you can do that, but just kind of be warned there. So you can get access for the Microsoft tools that you're used to, be it on the desktop or your smartphone, and get access to both relational or non-relational data like Hadoop. So quickly, some of the things you're going to see, or actually they're out now. You can get a Hadoop distribution on Azure or running on Windows Server. So, but you can certainly use Hadoop on Linux if you like. And we provide connectors at no charge for SQL Server and for a parallel data warehouse, so you can interchange data. Other things here. So we'll be delivering applications out in the cloud to leverage that. If you use Bing Maps, or if you use the Edmonton Real Estate Board to check houses, that uses Bing Maps. And I think we manage 7 petabytes of data a month of new map information. Social media, I'm going to show you a quick demo of how we integrate this with social media. Excel, a Hive add-in. So with Excel, with pivot tables, it's really sending a SQL statement to get relational data. So what the Hive add-in allows you to get that from the Hadoop data directly if you want to. And another nice thing they did is a support of JavaScript. So if you're a Java programmer, or naturally they support the Microsoft.NET programming as well. Okay, so I'm going to walk through this and then quickly show you a quick clip here. So there's a new tool out there, Microsoft Analytics for Twitter. It's a free download. And what we've done here is we've created a scenario where, and what we see companies doing is they want to marry big data with data that they have internally. And so step one is kind of this analytics for Twitter. I'll give you a blow-up of that in a second. And then you load the data onto the cloud or on-premise if you like. And then we use Hive to launch queries against this data. We use Power Pivot on front of Excel if you want to display the data in Excel. And so let's see now. So measuring sentiment, this is a big thing, and one of the top applications that people are doing with big data is the marketing folks. Like, what are people thinking about my product? But it could be more than just product. It could be, what do people think about my political party, my candidate? So if you're watching the election results yesterday, some of the things that they tracked were tweets. And what they did was, and maybe it contributes to why they were so far off, you know, the political parties would say this had so many tweets, but the tweets don't tell you the full story. The tweets tell you, okay, they're talking about the PC party, they're talking about a lot about the Wild Rose party. But what we can do with these tools, and new tools out there as well that you can get, is there are natural language processing algorithms to take a look at the tweets and give it a positive or negative tone. And it's a dictionary that you can also enhance as well. So what they could have done, and I'm sure they're going to do it the next election, is outside of the volume of tweets, we can measure the sentiments. Is it positive or negative on that candidate? And yes, I should be over. So I got to show this because this stuff, new ways of seeing things. And okay, so this, Perry launched this conference. We talked about Moneyball, if you've seen that movie, using analytics in a way that helped transform actually baseball. But in this case, what we did was we tracked the performance of Moneyball as a movie versus other movies, and we did it over time. And we took a look at tweets, and so let's see now. The big ball is Moneyball, and where is it? 57, 58. Coming any second. I want to do it over time. Okay, here we go. So we can actually show this. I haven't got it working yet. We can actually show this on PowerPoint, but this was done with PowerView. But we could do this in real time. And if you want the attention of you know, a CIO or CTO, you know, they probably get a little tired of seeing graphs and bar charts and stuff like that. You can be very interactive with this data. So think about new ways of presenting and boiling down all this big data. Okay. Now I'm going to close. Where are we here? Okay. All right. So going forward, we think Hadoop is great for unstructured data. Relational databases, not so good on the unstructured data, but they're really optimized for different kind of workloads. We think they're both going to continue to exist, still provide lots of value for your company. And what we're building are ways to integrate the two worlds, and through your familiar front ends, lower the cost of entry in leveraging big data. So if you want to get, I kind of skipped through a number of charts. If you want more detail on that, feel free to see me or Edouard at the table. And I'm going to enhance all of your resumes in a second here. Some factoids I didn't know about Microsoft. They're one of the top Apache sponsors. But so if you can't read it, they're asking if you have expertise in SQL. The person says no. Doesn't matter, write expert in NoSQL. So yeah, I should have mentioned the Hadoop. If you're familiar with Hadoop, they call this a NoSQL database, but it really means it's not just SQL, because you've got things like Hive. But now you're all experts now in NoSQL. Okay, sorry that was kind of fast and furious. They gave me 3 times the amount of time yesterday, but I hope you take that. This is a great opportunity, and there are ways of marrying it with your existing investments. And if you have any questions for us, see us at the table at the entrance.